Good morning, everybody, and thank you for joining us. I know we've got a few people that are still trickling in as we're starting this conversation, but let's go ahead and get started. The webinar today and the focus from the title, I think, as you can see, is 5 keys on how to improve your network performance with flow and wire data. And essentially what we're going to be looking at is how to use the multiple data sources that are traversing across the wire, across your network to improve the management, troubleshooting, and investigation around a lot of the performance and security challenges that you're facing, whether you're on the net ops or SecOps side of the house. What we're going to be doing throughout this webinar, because it does coincide with the release of Observer GigaFlow, is we'll actually be using that as a way to demonstrate the power of the variety of data sources that are traversing your network. So with that, I'll go ahead and get into the slides and introducing people. So my name is Steve Brown, Director of Solutions Marketing for the Enterprise and Cloud Division, and I'll be joined today by speakers Mike McGraw, who's our Partner Director. Hey Mike, how's it going?
I'm off mute. I'm good. Once the panic is over, trying to find the button.
Perfect. So be joined by Mike as well as Charles Thompson, Director of Product Line Management for VIAVI. Hey, Charles.
Hey, Steve.
Great. So, and together what we're going to be doing is really looking at, and we've kind of shaped this or organized this into 5 keys. So first, looking at defining the different data sources from logs through packets, understanding really the use cases. So in a almost a SWOT analysis, looking at the strengths and the weaknesses, or the strengths and maybe better put limitation, understanding really where these sources shine in management and troubleshooting and all the way down to resolution. And then really understanding how to leverage these multiple sources, using as a backdrop the Observer GigaFlow, where I'll turn it then over to Mike to go through a performance workflow as well as a security workflow to show the capabilities and when you're using these sources combined. So that's essentially what we're going to be looking to do today. As you've probably noted, all of the lines are muted. We're recording this so that way we can provide the broadcast for your convenience afterwards to either listen to again, or if you have to drop, understanding that you'll be able to access it again, as well as share it with anybody. So do feel free to use the chat function. You'll see that there's a questions function that you can use to ask questions of the speakers. Likewise, you may have noticed our emails before. I'll show the emails again. You can reach out to any one of us individually if you have a private conversation that you want to engage in that's of maybe a highly technical or sensitive nature. So when we look at the various data sources in terms of diving in, I think what we want to understand is really the role of each. So we were talking about SNMP, polling data, talking about machine, any sort of flow. And so generically that would be SFlow, JFlow, VPC logs, really the whole alphabet of what would maybe subscribe generically to that kind of NetFlow syntax, down to packets, the actual bits and bytes that are traversing the wire, and really trying to understand them on this continuum of real-time monitoring out through investigation, isolation, and then finally diving deep into root cause analysis. And what you're able to really see just from our experts and what we've noticed and put together are the various, I think, strengths as well as limitations where each one of these serves. So within real time, when you think about it, where you're getting alerts and understanding the basic condition, SNMP and machine obviously serve to really provide that real-time upfront understanding of what might be occurring potentially, or a first glance of some sort of anomaly. Diving in a little deeper when you're actually looking at what domain might be causing this issue is really where packets and flow start to shine, as well as when you're diving into root cause. Although all 4 play a role, that's really where having that granularity that those sources provide can be critical. And Charles, I was wondering if you wanted to add anything to that in terms of that understanding.
Yeah, Steve, I think, this is a great visualization that kind of summarizes a lot of insights all in one spot. If you look at that y-axis along the far left-hand side, you see availability at the bottom, errors, usage, and performance. And that kind of summarizes some of the key or target use cases for each one of those technologies. SNMP is fantastic for availability. Machine data provides really, really good insights into errors. Usage information, the breadth of flow makes it perhaps the best way to acquire usage information across the board. And then packets are, kind of the gold standard, if you will, for performance-based insights. And as we move along the x-axis then, from monitoring to investigation, isolation, and root cause, you start to see that the bigger role that performance data plays versus availability. When you're trying to do root cause analysis, you're not trying to say, is the asset available? You're trying to say, why is the asset performing the way it is at this moment in time? And really drill into the who, what, where, and when of what's occurring within that in order to be able to perform root cause analysis and obviously resolve the issue. So this visualization does a great job, I think, of summarizing not only the categories of technology that we're talking about today, but also the primary use case for each one of those technologies and how they all fit. And really what it comes down to, in my mind, is a holistic approach is going to involve insights across a multitude of technologies, and wherever possible, combining those insights together into a single logical stream of information so that an analyst or an engineer that's trying to understand problems that are happening within their environment don't have to move from data source to data source. The data source, at the end of the day, for the engineer, the analyst, should be irrelevant. It's the insights that matter. And I think we're going to talk about that as we get into the session here today. So.
Exactly. Thanks. Now, diving into each one of these a little bit further to understand really the why we're saying, for each role, whether it be at the availability level or at the troubleshooting level, needing this, call it, multiple data sources to effectively manage and troubleshoot, I think becomes evident, especially when you look at what are the strengths and what are the challenges with each one of these technologies. With SNMP, really easy to collect, easy to pull. There are a multitude of vendors offering solutions that are out there to give you that first glance. And in terms of as Charles was saying, availability, is it up, is it down? That's really the strength of SNMP from understanding how our device is operating on my network. The challenges are really, I think, one, that it does lack that granularity. It is just a single point in time metric. To perform the why is something not performing correctly or not performing as anticipated. Additionally, if you were looking at a user complaining, those types of validating or confirming that type of subjective measurement really isn't the role of SNMP. It's more that device machine focused. And Charles, I wasn't sure if you had anything to add here.
No, I think that's it. SNMP is everywhere. There's a low barrier of entry to leverage it. So to your point, it's fantastic for being able to get that kind of up-down information about individual assets or information. You can always use ping and ICMP and those types of things to be able to determine if a device is up or down. But when you want to drill into individual interfaces or maybe some specifics about what's traversing or what could traverse across the interface based on a routing rule or something like that, SNMP can do a great job of saying, yes, these two elements are both up inside of the device. But to your point, you don't get a lot of granularity, right? So that's why SNMP really fits well into that overall availability category, kind of right in there with ICMP.
Exactly. And I think that really what we're trying to do in going through these is just making sure that there's a clear understanding of the right tool for the right job. And from a holistic perspective, making sure that you have an all-encompassing view that allows you to manage issues and understand in real time what's occurring, making sure that you're prepared for any sort of risk that might occur and that you're able to mitigate and contain that risk, as well as that you have the granularity needed to be able to solve any issue. The next category that we wanted to look at was machine data. Generally speaking, most people access machine data through logs. Again, the strength is it's ubiquitous. It's all around. It's easy to pull the information from the infrastructure, whether we're talking the client side or server side details. And you can begin to understand performance, what's going on at a level and depth that's greater than SNMP. Or actually it's complementary to SNMP, I shouldn't say greater. And then in terms of the challenges, I think, again, it's that that ability to holistically focus on issues across the network can be a challenge, especially if we're talking about from the user perspective. And then taking it deeper in terms of granularity. Again, these are great metrics. You can put them together for trending purposes, but diving deeper into why is something occurring or why is this condition happening outside of the individual engineers or network professionals' intuition or experience can be limited by this type of data. And then the next form, as we go down that chart, talking about flow data. And I think with flow data, this is really, I think, a jewel in terms of people using it for certain within their core, but then understanding how you can gain that expansive breadth of insight cost effectively across your entire network. And not just talking about remote offices, but also talking about looking out into the cloud and understanding that this same form of flow data is being utilized, different iterations of it, by a variety of vendors to provide either views of the network performance, meaning that infrastructure, or the actual individual devices. So for example, as you're looking out into the cloud, not only could you tap into, for example, AWS has their VPC logs, but as you're putting out virtualized instruments, that's yet another view that you can gain to gain that insight into the cloud in a very lightweight, practical fashion to deploy. The challenges with flow and where I think packets really complement are when you get into that granular kind of root cause analysis, when you're starting to look at response times, when you're starting to look at really kind of reconstructing to understand maybe in a security example, what was taken, what was touched. That's where having those multiple forms of data can really help to augment the challenges that flow faces. And Charles, I wasn't sure if you had any comment as we're looking across these data sources.
Yeah, I think the thing to, everyone thinks about flow and they always think about it as kind of volumes, right? Counts and amounts. Who talked to whom and how much data did they exchange? And that was the foundation of what flow was all about, right? When NetFlow was kind of in its early stages and all the way up through version 5, really, NetFlow was all about who's talking to whom and how much data are they exchanging, and a little bit of information about what interface they're going across and so forth. And so if you want to get base usage information about what's happening within your environment, how is your network being leveraged, Flow is a fantastic data source. But Flow has continued to evolve, and Flow now includes insights that have to do with performance and detailed asset analysis and even some levels of DPI based insights. So Flow continues to grow and expand. Again, to your point from earlier, Steve, relatively low barrier of entry to leverage Flow because it's in so many of our devices. It's in so many pieces of infrastructure: routers, switches, load balancers, firewalls, application delivery controllers, right? All these different infrastructure elements that route conversations or pass conversations through them generate flow records in one form or fashion, right? NetFlow, SFlow, JFlow, IPFix, take your pick. But in addition to the infrastructure itself having the flow information, you also, in cloud-based environments, are starting to get the cloud providers providing flow insights as well. So a lot of different sources of flow content. It is, to your point, fairly ubiquitous. There is a low barrier of entry to leverage flow information. But the challenge is that even with the most advanced types of flow, you can be left with unanswerable questions, right? You can be left with a few too many why did that happen the way it did, or how exactly did that transact? I can see who's talking to whom, I can see their response time, but I can't necessarily drill down and understand the individual nuances that are happening within that conversation. So flow provides this fantastic breadth of visibility, right? It's a big, wide sweep of visibility across the entire landscape. Think about it as, the binoculars, right, of the environment. You can, see far and wide. But the challenge is that eventually you see something that you want to be able to drill into and get very, very granular against. And that's where integrating Flow with other technologies really starts to advance its value and its applicability, right? What if you could enhance Flow with some of that machine data that we were talking about, or some of that SNMP insight that we talked about, or even with packet data as part of your automated workflow? That's really where I see the biggest advantage for Flow is there's hardly a better technology out there to be able to gain a perspective of what's happening within the environment and what should I be interested in knowing more about. And then, the key is how effectively does a product or does a portfolio of technology allow us to drill in and gain some additional insight? So we're going to talk about that later, but Flow is for me one of the most exciting technologies just because it has such a wide use range and applicability for both performance and for security.
Great. In terms of the final area that we want to look at, and I think that this is one that people are very familiar with, so I won't belabor, but with packet analytics, really the strength of packets in network traffic in general is the way that it complements the other three flows to provide contextually the why something is occurring. Why from a performance issue, or there's some sort of contention issues that I need to troubleshoot. Why from a security standpoint of when a breach was occurring, I'm able to contextually understand everything else that was going on. Hugely important for investigation and remediation, hugely important for actually being able to get to that root cause and solve the issue accurately and quickly. In terms of the challenges, I think a lot of us are really aware of the limitations of, while we would love to have that visibility everywhere across the network, traditionally because of whether it be the volumes of traffic or budgetary issues or limitations of manpower, it's not practical to deploy across your entire environment up in the cloud. Rather, what typically happens in use cases is that our customers are focusing on where are the critical absolute areas where I need that depth of visibility. And as a consequence, the core becomes the area that is identified, or key offices or key areas where you need that type of constant visibility. And that's really where capture is placed and where that packet level visibility is used for managing and troubleshooting rather than placing it ubiquitously through. And I think that from this exercise, hopefully it's understood that there isn't one silver bullet form of data source that's going to provide you with everything that you need. And rather it's this constructive approach of incorporating all four that's necessary. And what we're going to take a look at next is, because I think that most of the people that are on the call are obviously very familiar with technologies like SNMP and machine data, as well as packets, is spending a little bit of time understanding how flows evolve, what new capabilities really exist, or I guess underutilized capabilities exist with Flow, and then bringing it all together within a single interface. And what does that look like? So with that, I'm going to go ahead and turn it over to Charles to take a deeper dive into Flow data.
Yeah, thanks, Steve. So let's kind of just level set everybody on Flow and talk a little bit about kind of the foundation of Flow and where it came from. So if we advanced into the next slide here, I think that we use the term Flow and we assume that everyone's kind of on the same page and using the same definitions here. But I think it's always helpful to just make sure we get everybody level set. When we talk about Flow, at least when I use the term Flow, I'm kind of using it in the way that it is leveraged most frequently, which is kind of a generic industry term for a collection of very specific technologies, right? So NetFlow is a specific technology founded by Cisco, JFlow is Juniper, right? IPFix is an IETF standard. There's a number of different very specific technologies that kind of get lumped together under this category of Flow. And I think part of the reason for that is that they do much the same thing. They sometimes do things in a slightly different way. Maybe one uses conversational sampling, maybe another uses packet-based sampling, maybe another doesn't do any sampling at all. But generally speaking, they're all kind of designed for infrastructures to be able to report on the data that they're passing or that's traversing their environments. And that's really what this is trying to do. And so you see that diagram along the bottom, right? Whether it's a router, a firewall, a load balancer, ADC, whatever it might be, packets are coming in and going out. They're being routed, they're being sent, they're being blocked, they're being distributed across multiple servers in a load balancer case. And in each one of those instances, records are being kept. Who talked to whom? How much data was exchanged? What TCP flags were set? What precedence value was being used? Those are just some of the more basic values that can be kept from flow data, all the way up and through, things like what URL was being accessed, what HTTP errors were being encountered, all kinds of potentially very detailed information that can be presented on kind of a record by record or conversation by conversation basis. But when we're using the term flow, think of it as just sort of an umbrella term for all of these very specific industry technologies. Now, if we advance to the next slide, you think about, so what are the sources of flow data? Well, as we're talking about here, right, generally speaking, it's infrastructure equipment. It's routers, it's switches, it's load balancers, it's firewalls in both their physical and their virtual form. And that's one thing to be cognizant of is that generally speaking, if a manufacturer of infrastructure equipment has flow-based capabilities in their physical devices, they likely have it to one extent or another in their virtual equivalents. So what that means is that if you were to take a virtual router and put it out in the cloud, that virtual router could very likely report on the same flow-based insights that a physical router could on one of your campus sites. The value there obviously being is that you have consistent technology and consistent visibility in hybrid environments where you're leveraging both, traditional on-prem, self-managed, hardware-based infrastructures, as well as off-prem, hosted, leveraged, cloud-based environments. And so, generally speaking, you're going to have a lot of consistency. And that's one of the values of flow is it works very seamlessly in both the traditional and the evolved hybrid IT environments. As far as the information that you're going to get from flow, it's not often tied to the type of device. It's more often tied to what the manufacturer has chosen to do and what level of resource you're willing to attribute to the flow generation. So the version of flow that you're using, the type of flow that you're using, and then the manufacturer's implementation and the amount of resources that you've got available to you to generate flow information from the device, it really become the gating items, if you will, in terms of how much information you're going to be able to get out of flow. Now, where does this flow data come from? Well, really, it comes from anywhere you've got infrastructure equipment. So, one of the most common locations for flow to come from is from remote branches, the edge of the network, if you will, or at least the edge of the traditional network. Nowadays, the edge of the network is a BYOD laptop in a coffee shop somewhere. But if you think about traditional campus-based environments, the edge of the network is, your remote offices, right? And so that's generally speaking where you see a lot of flow information being sourced. It's from the edge. It's as close as you can get to the actual consumers of the technology. And that's, one of the big advantages of flow. It casts such a wide net out to the very edges of your infrastructure. But you also see a lot of flow information being generated from the data center, ingress, egress, transition points, private cloud infrastructures. You see it where the application delivery controllers and the load balancers are being hosted. And then obviously from cloud-based environments, AWS, Google, Azure, they all have some form of flow that they generate natively. And then again, as we talked about, all of those software iterations of your traditional infrastructure devices also have the ability to generate flow data. So when you put one of those devices out into the environment, when you put a virtual NetScaler out into an environment, it's going to be capable of generating the same kind of flow in most instances that its physical equivalent would be able to. So that's where this data is coming from. earlier in the presentation, we went through all these different types of data, right? And we kind of talked about availability and errors and usage and performance, and we talked about where each technology would fit in. And as we talked about, flow in its traditional form fits in extremely well in sort of that usage scenario, right? Who's talking to whom? What are they doing? And then you can layer atop that some analytics and really get into things like profiling behaviors, and doing blacklist analysis, and those types of things for security use cases and so on. But one of the challenges you see with flow is that it's generally speaking fairly straightforward, fairly basic, and it provides a lot of information on what, but not a lot of information on how or why. How was that conversation able to occur? Why was A able to talk to B? And so on. And so as we started to look as VIAVI about what a portfolio of flow-based technology needed to have, it needed to have the ability to go beyond just flow. And so that's what we're going to try and walk through with you here, and we'll see if this resonates with the audience. Steve, go ahead and advance the slide here for me. And so what you're seeing here along the top of the slide, flow source, right? That's what we've been talking about when it comes to flow. Routers, switches, wireless access points, firewalls, the traditional devices that generate flow. Who's talking to whom? How much data are they exchanging, right? And that's kind of your basic standard flow. A lot of great information, a lot of fantastic insights. But when you think about how you could enhance flow, what would make it more valuable? You start to think, well, I'd really like to know not only who talked to whom, but which interfaces they talked across, and where those devices, those endpoints that are communicating, where they're physically located, where they're plugged into the network. Well, ARP tables and CAM tables allow us to be able to do that, but you collect those via SNMP. They're not natively included inside of a flow record. So you need a technology that has both flow and SNMP to be able to do the combination and stitch together the traditional flow record with additional insights from SNMP, from WMI, from LDAP, right? And these device-sourced informations. Additional to that, you start to think about, well, how am I going to see this information? How am I going to report on it and analyze it? And obviously, anytime you're doing an analysis, what you know is an endpoint of interest. A lot of times you know an application, a lot of times you know a VLAN, but almost always you know a user. And traditionally, our tools have always said, well, you can't know a user. You need to know an IP address, right? And so analysts and engineers and architects spend so much of their time trying to figure out what the IP address is that they should be researching. And in a DHCP environment, that's substantially more complicated than it would be in a totally static-based IP environment. And so if you start to think about what additional information could you layer on top of flow and SNMP, you start to think, well, what if we layered on top of that LDAP and user directory information so that when I'm interested in researching a problem, I don't have to go research the user, what DHCP server they got from, which IP address they had at a given time and day. I can simply just type in the user's AD login, the user's Windows domain login. And then I have a complete listing of all of their activity, simplifying the process to leverage all this additional information, right? And layer that on top of the traditional flow and the SNMP. And then obviously, this doesn't just work in traditional infrastructure environments. You've got to be able to work in cloud source-based environments, because I don't know of a single organization out there that doesn't have some type of initiative, some amount of data already in the cloud, some initiative to continue to evolve their cloud presence and recognize the benefit of cloud-based environments. And so all of this needs to function in addition to the traditional infrastructure flow-based content when you're dealing with AWS or Azure or Google. And so when you combine all of that information together, what we're producing is in effect what we call an enriched flow record. We're taking the traditional flow data, we're layering atop a ton of information, and that produces this enriched flow record, which takes us literally from a handful of flow insights to exponentially more information that's more easily accessible. And that's really a key there. And so that is essentially what we call Observer GigaFlow. And so on the next slide, we're going to drill into this just a little bit and really help you see what makes this different, right? So we've talked about, the top of the slide before had traditional flow. All the traditional devices generating NetFlow and IPFix, producing information like what you see in the blue cells there. This is just representative. It's not all the information that you could get from flow, but it's things like source IP address, destination IP address, packets, and bytes. Now, that is where traditional flow ends. Where enriched flow records expand is, in addition, we also pull the infrastructure and add in things like the layer 2 information, MAC addresses, and the CAM ARP table information for specific interfaces where devices are attached. Layering on things like user identity, right? So you can know the username and the domain that's affixed to that record. So you can easily query to say, I'm interested in Bob. I don't necessarily know his IP address, but I'm interested in Bob. And then we start getting into some of this how and why stuff, right? So flow tells us what transpired, but information from syslog and session data can help us understand how it occurred and why it was able to occur. Why was Bob able to talk, to the destination IP address 10.2.18.100? Well, because there's a policy rule in the firewall called R&D exception, and that allows for that conversation to occur. Mike's going to talk about some examples later where organizations say, well, A could not possibly be talking to B. We're saying, I'm sorry, but the records clearly show that A is in fact talking to B. Would you like to understand why A is able to talk to B? It's because of this rule or this policy inside of your firewall. And so there's so much information that can be gleaned when you start to enrich standard flow data with all these additional content sources. And that's why, as we said in the beginning of the conversation, no one data source is good enough. You have to be able to pull multiple data sources, but you can't simply say, I've got a bit of SNMP over there and some log data yonder, and I've got some flow around here somewhere. You've got to combine it. You've got to layer it together, and that's really what adds the value. And so this slide just kind of helps us understand, right? Where are the advantages here? If you think about what an enriched flow record really allows you to do, start off with devices that are not even capable of sending flow data, right? There's a lot of devices out there that are great infrastructure devices. They're going to be part of our infrastructure for a long, long time to come, but they just don't generate flow data for whatever reason, right? Well, the cool thing is that most of them do generate log data that looks a lot like a flow record. And traditional flow tools can't consume it because it's not flow. But GigaFlow actually has the ability to parse that log data and turn it into the flow portion of an enhanced or enriched flow record. So you can actually leverage insights from devices that don't even have the ability to generate flow. All right, but most prevalent flow sources don't have performance data. This is pretty common, right? Generally speaking, most flow sources are kind of doing, NetFlow V5, right? It's counts and amounts. It's volumetric information. Again, an advantage of these enriched flow records and what GigaFlow allows you to do is we actually have insights that analyze both directions of a bidirectional flow and applies this advanced analysis function to actually produce response time data from flows that don't normally provide response time data. And so that's all part of the enrichment process. So you can actually start to get performance data in addition to the volumetric data from devices that otherwise couldn't provide that insight. And then, the final point here, fine, but, flow vendors aggregate and deduplicate, so forensic value is oftentimes minimal. This is one of the challenges with every flow vendor out there. Everyone likes to brag up just how much they have the ability to deduplicate and aggregate information. Well, let's just, set the record straight here. There's no such thing as a duplicate flow record. It doesn't exist. There's uniquenesses in every flow record. If you're going to aggregate, it means you have to strip out those uniquenesses, and you lose forensic insight. You lose the value. GigaFlow, and what we're going to be talking about and what Mike's going to be showing, offers full flow forensics. That literally means that every flow in its native form is being retained for the most detailed analysis, high fidelity forensic insights. Whether you're troubleshooting performance, availability, error-based conditions, security vulnerabilities, you've got all the detail all the time. You're not losing data due to some deduplication schema or aggregation schema that I'm sure sounds great on paper, but at the end of the day, sacrifices the ability of the technology to provide answers when you need them. And so, I've referenced this term GigaFlow a few times. Let's just kind of take a step back here. What is Observer GigaFlow? Observer GigaFlow is literally a next generation technology that leverages enriched flow records, not just flow. And that's the key. It's flow data, it's SNMP data, it's LDAP data, it's log data, it's cloud-based insights. It combines all that information together, retains it all in its native form, allows for fast insights. And as you're going to see with the demo that Mike's going to do, this is a technology that allows you to gain incredible visibility across your entire infrastructure, hybrid IT-based environments, combined of physical and virtual, cloud-based, public, private, doesn't matter. Very, very quickly for both performance and security-related conditions. And that's key because, as we all know, operations teams are cross-leveraging technology all the time. There's no world in which network organizations are not being pulled in for security concerns. We did our state of the network study, and this year, 88% of respondents of a mostly network engineering background are saying, yeah, I spend quite a bit of my time actually dealing with security-related concerns and security-related investigations. And so being able to have security and performance in one technology platform with one set of insights across the entire infrastructure is key. And so, with that, I think what I'd like to do is, I'll stop talking. We'll stop doing PowerPoint. And let's actually get into the technology a little bit and give Mike a chance to actually drill us in. So with that, I think, Steve, I'll yield the floor and hand it over to Mike.
That sounds great. And I'm going to make Mike a presenter, and he'll dive into GigaFlow in the next 20 minutes and illustrate both how we bring together this data for performance and security management.
Thanks, Steve. You see my screen? Welcome to Apex, Steve?
Yes, I do. Yep.
Great. Okay. Thanks for everyone to sit there and listen to us. I hope we can be of information as to why we see ourselves as different. I suppose my own background is that I'm an old Cisco engineer from the 90s, the last century. Had a company that sold some built networks in Ireland here. You probably picked up a little bit of my accent now at this stage. I've been practicing it for a while. And what we did was we got very frustrated and naively started writing our own software to help to manage customer networks. And it became a company called Cranog Software. And I sold that to Flute Networks 2007. Ended up in there as a chief strategy officer. Worked with a guy called Doug Roberts, who's now the general manager in VIAVI, and our paths have crossed over the last year. He had packets on steroids, and I had kind of flow on steroids, and we said it's about time we started working together again. But what I wanted to do was I wanted to show you what Charles and Steve are giving you a good overview on. This is Apex that VIAVI have developed, and I'm very impressed on two aspects, and you can see why the synergy for me to come into VIAVI. One is I've got aspects of UI here that are unique to VIAVI. The other aspect is this simple number here. Really just, for me as a network engineer for 30 years, to be able to problem isolate, domain isolate this quickly using machine learning. So on the screen at the moment, what you're seeing is a very clean UI, but very, very powerful machine learning based system. All right. And again, the beauty of this is I can click through, and what you'll begin to see then is that once I get to an IP, I have access to GigaFlow. So we're only in 3-4 months. That integration is already in place, already launched. Let me take you back to the heart of my world, where I come from. So, as I said, Cranog, NetFlow Tracker, claim to fame was full flow forensics, we used to define it as. You sent me a flow record. I didn't know whether it was an important one or not an important one, so we decided we better store them all. And again, no different than any other tool that you basically have all the flow records and access to all the flow records. But we've added a number of differences, right? We should have, it's been 10 years since I've been on this stage, so I should have something to show. But as the lads are saying, I'm just picking a name. I get a relationship between a MAC, an IP, a name and the primary device that I've seen that name on related to the IP. I can click on the IP and I'm searching based on that IP, and I'm beginning to draw a picture of the traffic that's been generated by that IP. I can see the number of different applications. You can open that out, DNS, pinging, 443 traffic, HTTPS, and we've Facebook video. All right. So this was a very important kind of visual that I was working towards, and there's a lot on this page, and I might stop for a second and give you a bit of kind of real world. I never needed a search in NetFlow Tracker originally because my audience was not a security audience, but a networking audience. So if I said there was a problem at 10, 20, 30, 40, more often than not, most of the people on the call would know where 10, 20, 30, 40 is in their head. And they'd say, oh, it's Dallas or it's New York or wherever 10, 30, 40 is placed. And they would naturally go to the router that's servicing and looking after that network and look at the primary interface, WAN interface, to then define whether it's a good day or a bad day on that interface and whether they need to do some change and whether that's the root cause. Security or help desks don't work like that. Security or help desks don't know where 10, 20, 30 is. They don't have the benefit of having built the network in the first place or had to troubleshoot the network over years. So they go 10, 20, 30, 40, search the whole database. Now, if you come to a database, the scale and size of the number of flow records that I'm consuming, that's a bit hard in the database. And then when they're saying, show me for the last week because they're looking for patient 0, or they're looking for Shane that's ringing in saying that he's got poor performance yesterday, that's very taxing. So what we did was we built a search engine based on IP, MAC, user, whatever you want, attributes, tags, anything like that. And the idea behind it is that it gives you a free-form access into the network. Now, to be able to draw what I'm drawing here, I'm naturally assuming that I know where 10, 20, 30, 40 is hosted. And at the moment, in the case of Shane, he's only talking from one flow device, and that's the significance here. So one of the other ones is if I change it slightly and give you another example, we go to Google. And what I'm doing in Google, I'm asking, well, it's all same type of traffic, same view, DNS, TCP, and UDP. But what's interesting here, well, interesting for me anyway, is that I've got 6 devices here and 6 interfaces. Now that might not sound significant, but to me, what we're doing is we're deciding to draw the traffic view based on the device that has generated the biggest number of flow records. Now, a really good reason for me to come into VIAVI is this is what I was looking for. I was looking for UI. I brought this in myself, but I want to UI all of this. And we've a really exciting roadmap on how to take this data set and this powerful data set and realign it with a UI to make this very, very simple, right? But let's go back to Shane for a minute. And so again, picking these, now, again, the tool is called GigaFlow, the platform is called GigaFlow. The key here, though, is not just the flows. What was alluded to on the earlier presentation elements was that we had SNMP, and I mean, the S in SNMP is a killer, simple. What we're doing actually is not that simple. What we're doing is we're pulling back all the ARP and we're pulling back the bridge tables, CAM tables, switch tables, whatever you want to call them, and stitching together these type of relationships, user to IP to MAC, to interface layer 2, to VLAN to switch, and storing those over time. So that's what I call the stitching engine. Once we have that data, what it means then is that when we dig through, you'll begin to see, if I click through on, it doesn't really matter where I click, I'll produce a report. Now what I'll do is I'll just open up and put it into a table, and I hope you don't mind me bringing you into the weeds, but this is probably the only way I can prove what we've been talking about. So what we have here is, as I scroll quickly from left to right, I've got 30 columns. So these are my fields in my database. This is what we call an enriched record. So basically, every row here is a record. And what we've done is we said, right, we've a start and end time. We have the sender. I want to come back to traffic groups in a minute. So we have the user. That was inserted by us because we've gone and looked that up, right? And there's a whole set of fields here that can be used for numerous different reasons. You can see the MAC address here being inserted by the system, right? Interfaces. A whole series of information and extended fields back at the end here. First back, and I'm going to talk about that in a second. And these exit and event codes as well that can be reused for many different forms. One of the big areas that we're seeing is that effectively, yeah.
One of the questions that kind of came in, I just want to make sure that we stayed on this train of thought, because I think this is a great question. Gentleman's asking, enriched flow is good, but how do you collect them? If I have NetFlow from routers, how do you get more info from PCs? Do you SNMP all PCs?
No, the SNMP is effectively through the infrastructure itself. So what I'm looking to do is essentially, if I came into the customer's network, the first thing I do is go getting, say, basic flow. So this is a part of a journey. So what you would do is you would, if you hadn't NetFlow turned on already, we'd have to configure the routers. But let's say you had it going to an existing flow collector. I could take a copy of those flow records. Now, when I become aware of who the senders are, I look for permission, read-only permission to poll the router to be able to pull back the ARP table. Now, if the router is not the primary layer 3 device on that site, I then look for the switch behind, layer 3 switch behind. But it's the ARP table I'm looking for. And why that? Because that gives me the live relationship between an IP and a MAC. And I build up my own stitching table for that. The point then is that when I see a flow record, when I receive a flow record, we process it. And one of the processes is saying, look at the IP, look at the source, look at the destination. Do we have a known MAC address for that IP? Yes or no? If we do, insert it, right? In this case, on the screen at the moment, you see it's a TP link that's inserted for the IP, because it's the same IP address we filtered on this IP, right? And it's all external addresses, so obviously we would know the MAC address of the external addresses. So that's how, so I don't have to touch the end host at all, right? If I can then be allowed read-only access to the layer 2 switching infrastructure, I can then rationalize what switch port they're physically plugged into. Now we can talk about wireless again if people want. That's a slightly different mechanism, actually an easier mechanism, because the wireless controllers of today are very informative flow-wise. That wouldn't be the case, and they would know the MAC address themselves as well. Now, again, for any Wireshark heads out there, and I take it there's a few, there's a lot of things that you can do like that are familiar to you, that you can build filters like such. One of the ones that I'm keen to show is this. And what this does is, let me just run it and you'll see. So what I've just done is I've run a filter on the flag fields, right? And what I'm looking for is resets. Now, how flow works is that it's a series of packets, with the first packet being recognized as being unique by its 7 elements. So any packet that comes in afterwards adds to the byte packet, the byte count and the bit count and all that kind of thing. But also to the flag, it's a cumulative. So you could have any combination of flags in a flow. But what I'm able to do is filter on one of the values in that bit range to pick up on the reset. Now, what does that mean? What am I showing you here? I'm basically showing you that everything I'm storing is in a relational database. Now, a lot of people reading out there at the moment, it's like, oh, it's got to be elastic, it's got to be this, it's got to be that. Yeah, that's fine when you're dealing with a different type of problem. The seams of this world are dealing with a problem that they've been receiving human readable messages, which is syslog. And I do a certain amount of syslog already, which is to do for firewalls and proxies and load balancers. And with that in mind, it's a much more challenging environment to work in. So, I mean, I've got two technologies either side of me. I've got VIAVI, and I can see what they're doing and the pressure they're under in timing to achieve what they're best in breed at is packet capture, and packet analysis is huge because the speed that packets are coming at them. I'm looking at the scene market and watching them trying to translate a standard English written message into machine readable data, right? Both sides are under pressure with time. I'm sitting in the middle where the number of flow records has not jumped considerably, because when you speed the network up, I actually get less flow records. So what took 4 minutes, 4 flow records, are now taking 1 minute to 1 flow record. So I'm not under the same pressure. And I've taken that advantage and applied the stitching element and enriching element to the tool set, right? So we can scale to the biggest corporates in the world because we can, with the data set that we have. It's not like packets and it's not like Syslock. That's a key advantage. So let me jump on quickly. So that's how powerful that's how powerful the database is, right? Now, one of the other things I wanted to show you, just to jump a little bit around the place here, just on a track map. So we were challenged many years ago by one of the big banks over here in Europe to tell them when a printer wasn't a printer anymore. So now I've got the data in, what can I do with it? Well, I could find the printers and I could define what traffic they're supposed to be generating. Now, I'll give you a practical example of what the tool can do from a security perspective. Basically, I went into my biggest bank here in Ireland and I provided the tool, set it up for a pilot. It's now in live at the moment. And one of the questions they asked, they were using a scanner, and they said to me, how many devices do you think you have found in that local branch? And I said 55, they said 51. What were the difference? 4 ATM machines. So not only did they not know about the 4 ATM machines, they didn't know that they were plugged into the same VLAN as everybody else. What else I could tell them was that what switch ports they were plugged into, that are still, I could tell them the 3 applications that they were communicating with at any point in time. So what I did was we built a profile of what ATMs in the bank were allowed to talk to, those three applications. And basically we alert based on traffic that do not conform to those traffic profiles. We kind of call it whitelisting, profiling, or acceptable usage. We haven't decided on which one to call them, but you'll hear us interchange those terms. And that's what's happening with the profiler exception, the red here, over time. The other one that's appearing here in this demo is sinners, as we call them, which is something that has created a flow record, like the TCP flags I was showing you, but never sent an ACK, which meant that it tried to connect to something, never got a reply. Now that could be misconfiguration, it could be a server gone offline, or more likely it's something a little bit more sinister, something scanning the network. And the last one, which sounded strange at the time when I was asked, because the same guy asked me to develop the search, asked security genius in security over here in Europe, asked me to build a tool to check for 11,000 IPs. And I go, what's that for? And he says, blacklisting. And I naively thought, well, isn't the firewall and intrusion detection systems doing that? And he said, well, he doesn't believe the packets are getting to the intrusion detection system. And we proved him right, that we built this system. The software downloads up to 30, 40,000, whatever number is active at the time that we're live. And it checks against those IPs that none of your traffic is matching source or destination for that. So I'll just give you a very quick little look at that. So blacklist destination, which is the most concerning, because your device is now talking back out. And this is the type of forensics. So we can see what list it came from, what device saw it, what interface it came in, what interface it went out, and what type of traffic it was, how many packets. That's a little bit more benign because we know there wasn't an actual full connection. Right? But there's that type of forensics within the tool. Very quickly, I'm very keen to talk to customers at the moment. I'm doing a lot of work on something that's probably close to a lot of your hearts is SD-WAN. You're either kicking it around the place in a lab, or you've started to go live in it. Either way, there are certain blind spots within the technology. It's a very complex technology. It's trying to bring a lot to the table. You've got local internet connectivity, you've tunnels, you've routing, but most of all, the one thing that interests me the most, you've got a firewall. And there's two forms of these. Either the firewall is on the edge box or the firewall has been hosted. If the firewall has been hosted, it could be using Palo Alto or Checkpoint or something like that. So which means that the tool set to what I call the element manager to manage that infrastructure is mostly derived around looking at the traffic. Not derived around the traffic, but around the actual configuration of the infrastructure to make this thing work. It does some performance stats, and these tools, these SD-WAN vendors do have good user interfaces, but they're not in a position to record the consequence of what they're doing. And I'm very fascinated by local breakout. I'm fascinated by the fact of how the firewall function works on these boxes, and the use of the likes of Zscaler and access to the Zscaler data. So what we're trying to do is put an independent package together to allow people to see exactly what's going on, to oversee SD-WAN, along with everything else, legacy and what you're trying to do new, right? So Steve, I'll hand back on that. I've probably forgotten about 14 or 15 things. I'll just mention this very last thing, right? First packet response, my pride and joy. I nearly forgot about it. I was tracking down the challenge with trying to track down for the credit card transaction for one of my large retail customers. And what I found was I got two flow records, the one up and the one that came back down on the WAN, and I subtracted the time and I could tell them in milliseconds. The challenge was I had to go hunting for that. What we did was we built a system to pick up on that and derive what the actual first packet was. Steve, I've done my bit.
Yep. No, and I appreciate that. That gives, I believe, everybody a good sense of the value, the utilization of multiple data sources, understanding of how we're able to bring that together for performance management for security. We definitely actually have quite a few questions, so I'll ask those. Just a final plug. What I would do is from here, next steps is be sure to check out viavisolutions.com/observer GigaFlow. Up there, we've got the use cases, the features. There's a great white paper written by analyst expert Chris Greer on packets versus flow, really laying out the case for each. Additionally, you can always go and request a GigaFlow demo. So we're happy to talk and walk through. Mike is happy to spend his time with you. Had questions on okay, so actually we have one that is in terms of isolating potential vulnerabilities across the network. What sort of capabilities does GigaFlow have around this? Mike, I don't know if you want to answer that.
Yeah, it's probably one of the points is one of the things that we're working on. One of the things I made up a title called Partner Director, and one of the things is to working with other vendors. So I'm not here to achieve everything. So there are very good scanners and vulnerability scanners and pen testing and lots of other tools that do certain functions. What they don't embrace potentially is the network infrastructure itself. So I've engaged with with customers where I fed vulnerability scanners with devices that I knew that they didn't know, right? So there's a number of different ways of interacting with that. So I'm not particular. But if the other thing then is WannaCry and things like that, we've ways of picking up and watching 445 traffic and watching number of transactions based on that type of traffic. So not an island, working together with other people.
Got it. One final question, and then I'll let everybody go. There's a gentleman who's considering, he has one of our competitors, was looking at Apex to replace with GigaFlow. Is he able to see bandwidth usage for each link?
Oh yeah, I see. I skip over that because I did that 20 years ago. Yeah, yes, absolutely. Quads, anything you want to do on that. Yeah, that's all there. Yeah, sorry, I keep forgetting to do the basics.
That's perfect. So with that, want to thank everybody for your time. Please feel free, if you still have questions, to reach out to us individually. And thank you very much for your time today. It's been an absolute pleasure to be able to